chances to take that one. Okay? We'll take the best of the 3 scores. All right, so here we go. Get ready. We go. So u plus v in component form. So the first thing I'm going to do is I'm going to find the component form of u. So u, vector u, is going to be 35 times the cosine of 25 degrees, comma, 35 times the sine of 25 degrees, which is going to be approximately 31.72 and 14.79. Okay. V is going to be 50 times the cosine of 120 degrees and 50 times the sine of 120 degrees. That's going to be negative 25 and 25 times the square root of 3. So then vector u plus v, 31.72 plus negative 25 is 6.72. 14.79 plus 43.3 is 58.09. Component form of that one. Magnitude then is going to be 6.72 quantity squared plus 58.09 quantity squared, and then take the square root of that, and so I get the square root of 3,419.95, so I get the magnitude of u plus v is 58.48 units. Direction angle of u plus v. I'm in quadrant 1 because I have positive horizontal and positive vertical. So I'm in quadrant 1. So theta is my reference angle, and that's going to be the inverse tangent of 58.09 divided by 6.72. And when I do that on my calculator, I get a reference angle of, a direction angle of u plus v as 83.4008 degrees. Agree? Okay. All right. Fantastic. We're going to flop back into navigation today. Okay? But with this navigation, now we're going to add in the simple fact that if you look out the window, you see the steam coming out of the stacks over there, but it's not going straight up, is it? Why? Because of the wind. Okay? And so that plays a factor on things. When you're flying in a plane, okay, for all you DECA people flying to Orlando at the end of April, okay, when you're flying in the plane, the pilot is constantly, or the computer on the plane, I should say, is constantly recalculating where it is that you need to go, so it adjusts. Because when you fly a great distance, the wind takes effect on the plane. And so you can aim directly. If I'm Wausau and Tess is Orlando, and and I aim directly for it, as I'm flying towards Orlando, it's going to drift me over, okay? And then it might drift me back this way because I hit up another wind or something like that. And next thing you know, I end up in Houston, okay? Where KB's at, okay? Which isn't Orlando. Better now. Okay? We're out of space. Okay? So remember, in navigation, north is 0 degrees. East is 90 degrees. South is 180 degrees. West is 270 degrees. Now, I say that because when we find reference angles, we have to go off of that now. Okay? Reference angles now go off of that. Okay? So that tweaks our things a little bit. And we have a wonderful type of equation that all of you should write down. And we came up with this equation. All three of us are teaching the exact same thing. Aim plus wind equals, I got to move it over a little bit. Aim plus wind equals true flight. Actually, we'll just say true there. Aim plus wind equals true. Okay? So if the wind is blowing, okay, if I go back to I'm Wausau, Tessa's Orlando, okay, and the wind is blowing from Ian to Cassidy, okay, I'm not going to aim at Tess because I'm going to end up at Gina, right? If the wind is blowing that way. So I'm going to aim over by KB because then the wind will push me right to Tess. Okay? If the wind is blowing that way. If the wind is blowing the other way, if the wind is blowing from Morgan, okay, now I'm going to aim probably in here. Okay? About how it, and all of that can be solved with vectors. Okay? So you just find the component form of all the vectors, and boom, you got it. Aim plus wind equals true. Or aim plus current equals true if we're on a ship and there's currents going. Things of that nature. Okay? All right. So a plane has an airspeed of 450 miles per hour on a bearing of 150 degrees. The wind is blowing with a bearing of 60 degrees at a velocity of 50 miles per hour. What is the true course and ground speed of the plane? Okay? So, you've got the plane. The plane has a bearing of 150 degrees. That means that is down here. Agree? So the plane is going down like this to the southeast. What is the trig angle for this one? What's the trig angle? Nope. What? 300. Yep. Okay. Trig, remember, comes here all the way back around. Okay? That's important because when I go to get the vector of my plane, which would be the aim, that's going to be 450 is my velocity, my magnitude, if you will, times the cosine of 300 degrees, and 450 times the sine of 300 degrees. When we're using vectors, like yesterday and the day before, that's a trig angle. That's different than a bearing angle. So you have to convert it. Do the calculations. I get 225 and negative 389.711, but really that's 450 times the, what's the sine of 300? Negative square root 3 over 2. So that's really 225 square roots of 3. Okay. Now, we got the wind. The wind has a bearing of 60 degrees. What is the wind's trig angle? No. 30. Yep. Bearing comes off of up top, okay, and goes counterclockwise. Trig comes off of straight right and goes clockwise. Trig comes off of straight right and goes counterclockwise. Trig is like unit circle, yes. Okay. So the wind here then, what's it? 50 miles an hour is my velocity of the wind. So the wind is 50 cosine of 30 degrees, 50 sine of 30 degrees. So that's going to be 43.3013, comma 25, which is really 25 square roots of 3. Because 30 degrees is on my unit circle. Well, I want you to be as exact as possible for as long as possible. You know what I mean? Okay. So now, my true flight, which is what the question was asking, my true flight is going to be my aim plus my wind. Scroll back up so I get both of those on there. So that is going to be the vector of my true flight is going to be 225 plus 25 square roots of 3 and negative 225 square roots of 3 plus 25. Or, simply put, my true flight is going to be 268.301 and negative 364.711 if we rounded to 3 decimal places on that. Yes? No? Totally confused.
Totally, yeah.
But you weren't
Don't
here.
worry.
I'm not worried about you.
We'll get it.
You'll get it in no time. Everybody else good though? Okay. Were you confused, Luke?
No, I'm good.
You sure? Because this is a great time to explain.
I think.
Okay.
Okay. Well, how do you find the 25 square roots of 3 or the
Just use a unit circle instead of rounding.
What do you
Again,
mean by that?
what do you mean?
Because-
Well, because both 300 is a unit circle angle.
Yeah, that's fine.
Okay.
But how do you get 25? Just by both by 2 or what? Like you went from 50 to 25.
Well, what's the sine at 30 degrees? A half. So what's 1/2 times 50?
25.
That's where I got 25 from.
The square root of 3.
What's 50 times the square root of 3 divided by 2? 25 times the square root of 3. Okay? Alright? Now, I'd love to say that we're done with this problem, but we're not.
Oh.
Because what do we need?
Circled it.
We need the magnitude. Because the magnitude is the plane's velocity. Okay? So I need the magnitude here of my true. So that's going to be 268.301 squared plus negative 364.711 squared, and then take the square root of that. That's going to give me my true ground speed. So this plane is actually flying at 452.769 miles per hour. So the wind is helping it by 2.769 miles per hour. True direction. Which quadrant am I in with my true vector? Which quadrant? 4, right? Right? 4? Okay. Positive, negative. Positive on the horizontal, negative on the vertical is quadrant 4. Okay? So if I find my theta prime, that's going to be the inverse tangent of 364.711. Remember, I drop the negative signs when I'm finding reference angles. Over 268.301. That gives me a reference angle here of 53.6598 degrees. Right? Okay. Little side action here. that reference angle is right here. Correct? No. No.
90 plus?
Why 90 plus?
Because it's a navigation.
Because it's navigation. It's navigation. 0 is there. 90 is there. So it's 90 plus my reference angle for the bearing.
I'm gonna be in.
So my true bearing is, what is that? 143.66, we'll call it, degrees. What's up?
How do we know it's in that quadrant and not any of the other ones? Is it just because that's where the plane started out, or?
Positive on the horizontal component,
Oh.
negative on the vertical component.
Okay. And is it the true flight vector?
Yep, that's because that's what we're looking for.
Okay.
Okay. Now, I will tell you this. It takes a little bit to do these problems. Okay? Because you got to think. You have to think about these problems, about what you're doing and where you're going. Okay? A plane is flying with a bearing of 300 degrees at a velocity of 500 miles an hour. Because of the wind, the plane has a resultant velocity of 525 miles per hour and a bearing of 305 degrees. Find the velocity and the bearing of the wind. Okay? So, start with the plane. And the first one is actually the aim. Okay, the first set of numbers is the aim of the plane. Because the second set of numbers said resultant velocity. So a bearing of 300 puts me over there. What's my trig angle over here? It is not 135. We got it. Look, 150. So my aim vector is 500 times the cosine of 150, 500 times the sine of 150. Which is that. But truly, the plane is flying with a velocity of 525 miles per hour and a bearing of 305. degrees, which makes this be a trig angle of how much? 145.
Can you show me my triangle, please? Okay, I can do the other side.
What do you mean?
The other side of the circle.
Because trig always comes off the right. And it goes counterclockwise. With me? So that gives me negative 430.055 and 301.128. Right? Aim plus wind is true, correct? Right? So true minus aim gives me my wind. So true minus aim is 2.95788 and 51.1276. Which quadrant are we in? We're in the first quadrant. Okay. How do I find the magnitude of my wind? Square those. Take the square root. That gives me my wind is at 51.2131 miles per hour. Get it in there. Nope, nope, went too far. Okay. Don't be packing up yet. We ain't done. I get a reference angle here of 86.689 degrees, right? So because we're in quadrant 1, how do I find my bearing angle? How do I find my bearing angle in quadrant 1? 90 minus my reference angle. So my bearing angle of the wind is going to be 3.31103 degrees. Good good times. You only get better at this stuff if you practice this stuff. The purple packet is all practice on this stuff. That is the packet that will be due next week, Wednesday. Purple, due Wednesday.
For everyone?
For everyone. Yep.
When